Okay. We're looking at making a determination about the accuracy of being able to locate the position of the piston as the piston moves inside of the cylinder. And you can see here that here's the piston 1 transceiver. And the piston 1 transceiver is sending radio frequency energy down the piston transceiver channel. And that radio frequency energy is then being radiated out into the cylinder wall transceiver channel. And the channel that we're looking at right now is cylinder wall transceiver channel E. And if we look at the magnitude of this opening in the door here, we are setting this doorway at a very small opening. So you can see that here is the transceiver 1 and here is that doorway, and we'll make that doorway as small as we can make it with respect to it being open enough to let some energy through. So if cylinder wall transceiver E says that it is receiving energy from piston transceiver 1, then we know that piston transceiver 1 has to be at least here. But actually, if we're only saying that we're receiving energy or we're not receiving energy at the level of cylinder wall transceiver E, then it turns out that piston transceiver 1 could actually be here also, because this location is where piston transceiver 1 is broadcasting through a doorway that's as open as it can get. So clearly we would be picking up radio frequency energy, and if we looked some more, we could see that actually piston wall transceiver 1 could move all the way over to here because there's a little bit of a doorway here opening. So if we're only just saying that we are receiving piston 1 transceiver energy at the level of cylinder wall transceiver E, all that tells us is that piston 1 transceiver is somewhere between here and here. And if you look at the distance that it moved, we know that this distance, not in these drawings, but this distance in reality is 2 millimeters. And so when we move the piston over, the edge of this piston transceiver channel moves from here, which is about 2 millimeters, all the way over to here, which is another 2 millimeters. So our total distance of motion for piston wall transceiver 1, if all we're saying is that we picked up energy at cylinder wall transceiver E, is that we are locating this to within an accuracy of plus or minus 2 millimeters or a range of 4 millimeters, because we can say we're not picking it up with cylinder wall transceiver C or cylinder wall transceiver D, and we're not picking it up at cylinder wall transceiver H or I or G. So we know it's in here somewhere, but we do not know its specific position with an accuracy any greater than going from all the way over here to all the way over there. And the question that we're going to look at trying to answer is if we actually measured power levels, is it possible by measuring power levels that we can get a more accurate understanding of where is piston transceiver 1 with respect to whichever cylinder wall transceiver we're talking about? So, for example, cylinder wall transceiver E. Are we able to say with more accuracy than plus or minus 2 millimeters with a range of 4 millimeters, where is piston transceiver 1? That's our question.